Okay, name the figure GHIJ with vertices. Okay, we're going to do the same thing as we did on these two. Let's get G to H, H to I to J, and J to G. We're going to get the slope and the distance. Okay, so from G to H, from -1 to 4. -1 to 4, you're going up 5. So our slope starts with 5. From -9 to -2, you're going to the right 7. So the slope on this right here is 5 over 7. 5 times 5 is 25. 7 times 7 is 49. If you add those up, you get 74. 25 plus 49 is 74. Let's do HI. From H to I. From 4 to 3, you're going down 1. And then from -2 to 4, you're going to the right 6. Okay, so if you get the square roots of those, it's 1 times 1 is 1, 6 times 6 is 36, square root of 37. These right here are nowhere close to being 90 degrees, aren't they? I to J, from 3 to -4. From 3 to -4, you're going down 7. And then from 4 to 9, you're going to the right 5. Notice these are almost the same, aren't they? So this is going to be -7 over 5. It's going to be the same distance, isn't it? The square root of 74. And then from J to G, -4 to -1. -4 to -1, you're going to the right 3, or you're going up 3. And then from 9 to -9, you're going up 18, right? You're going to the left 18. It's going to be -18. That's going to simplify to -1 over 6. And this is going to be a huge number here. 18 times 18 is 324. 3 times 3 is 9. You add those up, you get the square root of 300. 324 plus 9 is 333. So we have two equal sides, but these two sides are not equal, aren't they? We have a parallel sides, and these are 90 degrees, right? So this is just going to be a quadrilateral. This is not going to be anything specific here. Actually, it's a trapezoid, isn't it? This would be a trapezoid, wouldn't it? This would be a trapezoid because we have one set of parallel sides and one set that's not, isn't it? So this would be a trapezoid. Tricky. Okay, we have one set of parallel sides, one set that's not parallel, so this right here is going to end up being a trapezoid, and these two are the same. It's actually going to be an isosceles trapezoid. First time I've done one of these. So this right here would be an isosceles trapezoid. These two sides are parallel. They're not the same length, but the sides that aren't parallel, these would be the legs, and they're the same distances, aren't they? So this trapezoid would look like this. Okay? These two sides would have these distances and these slopes, and then these would be the parallel lines right here. Okay, right here, we're going to do one more. Which of the following terms apply to it? And you got to do the same thing. We got to get from P to Q. This kind of gets old. P to Q. Then we're going to go from Q to R. Go to R to S. And then we're going to go from S to P. Find the slope and find the distance. So from P to Q, from 7 to 5, you're going down 2. From -1 to 5, you're going to the right 6. That's going to be a -1/3. 2 times 2 is 4. 6 times 6 is 36. Square root of 40 for the distance. Q to R is this one. 5 to -1 is down 6. And then 5 to 3 is to the left 2. So we would have a 3 slope, and it would be the square root of 40 again. These numbers aren't changing, are they? And then let's go from here to here. -1 to 1 would be up 2. And from 3 to -3 would be to the left 6. That's a -1/3. Notice we have perpendicular sides, and these numbers aren't changing. It's still going to be the square root of 40. And then from here to here, from 1 to 7 is up 6. And from -3 to -1 is to the right 2. It's going to end up being a 3. So these two are parallel, and it's going to be the square root of 40. All the sides are the same. So it's either a rhombus or a square. It's not a rectangle. Do we have perpendiculars, we have perpendicular sides, don't we? So it's not a rhombus, it's a square.